Open our bay doors.
I'm sorry, Dave. I'm afraid I can't do that.
What would you do with a brain if you had one?
Do? Why, if I had a brain, I could...
Miles per hour.
I could while away...
46.56 degrees.
Thanks, Carol, and thanks for coming out today. My talk is going to be on climate change and the natural world, and awareness and communication about climate change is imperative now more than ever before. So really, thank you for coming out today. And I thought it was fitting, since the film is Microcosmos, and we're looking at the very small, to start out with the very large, and that is the cosmos. And that is what we consider, that's the observable universe. And when we're thinking about a system has many working parts, and we use boundaries to define it. Now, this is the largest boundary that we can conceive, our observable universe. And within that, we can break it down into smaller parts. Galaxies, smaller than that, are star clusters, and even smaller than that is our solar system. And our solar system has 8 planets orbiting our sun. And back in 1968, when we landed on the moon, we took this picture of Earth. And it was the first time that we saw Earth from this viewpoint, far away, looking so small and fragile and delicate. And all our moving pieces on Earth work together just on this one small sphere. And within the Earth system, there are 4 primary spheres, 4 big components, one of which is the atmosphere. And the atmosphere is this thin veil surrounding Earth, composed of gases, the air we breathe, nitrogen, oxygen, argon, and it also contains clouds and particles. It's where our weather events take place. Then we have the lithosphere. This is the crust and the uppermost part of the mantle. It's made of rock, and so change happens very slowly on the lithosphere. The biosphere is all living things on Earth. Trees, you, me, or animals, plants, insects, that's all part of the biosphere. And then what I like to think of, the piece that clearly connects all 4 spheres is the hydrosphere, which contains all the water on Earth. And in the atmosphere, that would be in clouds and precipitation. We have lakes and rivers, and underground, in the lithosphere, we have groundwater. And as far as the biosphere is concerned, humans, we're made up of 60% water. So all these different spheres, the hydrosphere, the lithosphere, the atmosphere, and the biosphere, they interact and they talk to each other. They send information back and forth. And so what is climate? Well, weather is temperature, precipitation, wind, atmospheric pressure, humidity. All those weather events averaged over a long period of time is what we call a climate. And there are different climate zones on Earth. There's desert climates and Arctic climates, and forested. So you can see those in these images here. And you've heard that the climate is changing. And there are some different indicators that show how the climate is changing. So within the atmosphere, we have gases. And some of the gases are what are called greenhouse gases. Now, the largest greenhouse gas is actually water vapor, which we can't do too much about. But then there's also carbon dioxide, and methane, and ozone, and nitrous oxide. And looking at their structure, they can move around a lot. They can vibrate at these different frequencies. And the Earth is a system. So if you look at that greenhouse in the picture, think about that as equivalent to Earth. So Earth gets over 99.7% of its energy from the sun. And that's in shortwave radiation that comes into Earth and reaches the surface. But then the Earth itself and all the organisms living on the Earth also emit energy in the form of long-wave radiation. And that long-wave radiation can't escape back into space, but because of the greenhouse gases are able to absorb much of that long-wave radiation, and they re-emit it back to Earth. So they act as almost like a blanket covering Earth, holding in that energy. And so really what is happening here is that the energy within the Earth system is increasing, and specifically it's increasing in our atmosphere. So we have more energy, and we also see a rise in temperature. So air temperature has been rising, and also the ocean temperature has been rising. So if you notice these circulation patterns, so this is how the ocean moves around the planet. It has these very specific patterns that it follows, and it's driven in large part by differences in temperature. And things like to go from higher energy to lower energy, so they flow from higher temperature to lower temperature. So the red lines here indicate higher temperature, the blue lines indicate lower temperature, and the purple are a mix in between. And I'd like you to notice what is going on up in the Atlantic here, where we are. So we have warm water coming up through Europe, and cool water coming back down past where we are over here. So that's why if you go from Massachusetts across the way to the same latitude in Europe, they have much warmer climate conditions than we do. It's all because of this global ocean circulation pattern coupled with the atmospheric circulation pattern. And if the temperature of the ocean warms, the circulation pattern will change, which will cause these different climate zones to change. Another sign of change is ocean acidification. Now, carbon dioxide in the atmosphere can dissolve in the oceans, and it mixes with water to form carbonic acid. And carbonic acid lowers the pH of the oceans. And you've heard about the coral reefs being bleached. And the way that works is that the plankton that lives in the coral reefs gets, the plankton and the algae that lives in the coral reefs gets very stressed when there's low pH. And so it leaves. And so the coral reefs lose their color. And the oceans are considered a carbon sink. And the colder the water is, the more gas, the more carbon dioxide it can hold. So just think of your soda. When your soda is really cold, it's bubbly. But when it warms, it gets kind of flat and it loses its carbonation. The same thing happens with the ocean. So as the ocean warms, it won't be able to hold as much carbon dioxide. So that'll be re-released back into the atmosphere. Once again, increasing the energy in the atmosphere, right? The greenhouse gases, they're going to be holding in more of the heat from the Earth. And also because of that, because the ocean's warming, our ice sheets are decreasing and they're melting. And this shows the Greenland Ice Sheet here. And in 1996, it had a much bigger aerial coverage of ice. And then you can see in 2007, that coverage is much smaller. And today, it's even smaller than that. And the problem is polar bears and other animals that live up in the Arctic, they are getting stranded because their ice is melting. So you can see the little polar bear stuck in the ocean. And then the meltwater has to go somewhere. So it goes back into the ocean, right? And so what happens when you send the meltwater back into the ocean? Well, sea level rises, right? It's going from ice and it's going into the ocean. And so this shows what would happen to the southern tip of Florida after just 6 meters of sea level rise. Since Florida is at such a low elevation, it'll be completely underwater. And even today, on these sunny days, since with sea level rise, they're getting ocean water coming up through the storm grates and just filling the streets. It's already happening. And we can track precipitation patterns, and this shows precipitation patterns from 2014 to 2015. And what this shows is the red is heavy rain, and the green and yellows are more lighter rain. And it shows how the rain moves and circulates across the globe. And I'd like you to look over at California up in the top right here. You can see that the rain is not really hitting California. California's in a drought, so it's not getting rain. And with climate change, the wet areas are going to get wetter and the dry areas are going to get drier. And France, over here, where Microcosmos takes place, is not receiving very much rain. And it's predicted that in the future, it's going to receive much less rain. And by the end of the century, it could receive up to 10 to 20 inches less rain a year. And I'd like just to direct you to some really helpful resources. NASA has a webpage called climate.nasa.gov, and they have this dashboard that give you the vital signs of planet Earth. So like you would monitor your heartbeat or your temperature or your body pressure. This shows you the amount of carbon dioxide in the atmosphere, and it's constantly updated. So right now we have 404.42 parts per million carbon dioxide in our atmosphere on average. Our global temperature has risen 1.7 degrees Fahrenheit since 1880. Arctic sea ice has gone down by 13.3% per decade, and the land ice has also decreased. In addition, sea level rises 3.4 millimeters per year. Now, with Microcosmos, it's going to take a whole different look at what is going on. So Microcosmos was filmed 20 years ago in a French meadow, and they focus on very small invertebrates and insects, and so this meadow is huge to them. It could be their cosmos, right? So time passes differently to them. Everything is just much larger. This drop of rain is like a big pond to them. So think about what could happen if France started to dry out and was in a drought-like condition. So how would climate change impact the small critters that you see in Microcosmos? And how does the small impact the large? So this shows all ecosystems have what are called primary producers, or autotrophs. So that we are grass here. They take energy from the sun and they convert it to biomass, in addition to taking in minerals and nutrients from the soil. And then the primary consumers, the slug here, this little heterotroph, this vegetarian, will eat the grass, and the toad eats the snail, and the hawk eats the toad. And when they die, the mushrooms, or the decomposers, eat them and convert them back into nutrients and minerals that are sent to the soil, and the whole cycle starts over. But if you break any part of this chain, it impacts the entire system. So if the snail can't get its food from the grass because the grass has died from drought, then the whole ecosystem falls apart. And one last thing, I saw this morning, actually. This is a little article that was posted on the BBC, and it says the world now sounds different to how it did a century ago. And this is an article talking about soundscape ecology, and it's the use of sound to monitor diversity and health of an ecosystem, and then track the impacts of climate change on ecosystems. And Bernie Krause is a pioneer of soundscape ecology, and he's been working on it since 1968. And in 2004, he started collecting recordings on Sugarloaf Ridge State Park. And the recordings in 2004 included rich chorus of bird song over a background of a trickling stream. And then by 2015, there were no more bird songs. All that could be heard in the recordings was a stream. So because of the drought in California, a site not far from our home in Northern California, he said, where the effect of global warming and resulting drought has created the first completely silent spring I've ever experienced. So in Microcosmos, you're going to hear some sounds you've never heard before, and they're going to be amplified, and it's going to be coming from all the different insects and invertebrates. So just think about those sounds, and when climate changes, and if a drought happens, those sounds would also change. So I'm going to be around after the film for questions if you have any. So Thank you again for coming out and enjoy the feature.